Shall we start the lecture, students? Better, no? So you don't have to waste time. Right, you can see my screen, isn't it? So we are going to start today's lecture. This is the fourth lecture under Data Science and Analytics module. This is classification, okay? So these are the contents we are going to cover today, students. So if you can remember, last week we have discussed clustering. And before discussing clustering, we discussed two machine learning techniques which are supervised and unsupervised, right? Supervised and unsupervised. What is clustering? It is what kind of method? Is it unsupervised or supervised? Clustering, is it supervised or unsupervised? I'm sure you know. Can you remember what is supervised learning? Supervised learning is what? Supervised learning is you are training a machine using a labeled data set, right? Unsupervised learning is what? You are giving the data set to the machine and machine is going to identify patterns. So having said that, what is the category clustering is falling in? Any idea? So I told you what is supervised and unsupervised learning. Now, which one clustering is which kind of technique? What is the technique? Can't remember. So that is not a good thing, right? So these things you should be able to remember. Okay, yes, good. Thank you for the answer. I don't know what's your first name is Puta. The answer is correct. Clustering falls under unsupervised learning, right? So clustering is unsupervised. Right? What we are going to discuss classification is actually supervised learning. So today's lecture is classification. So we are going to look at what is classification, what are the applications, what are the steps you have to follow in classification, and we are going to look at different techniques, and out of that we are going to learn one technique which is decision tree, and we will look at the things like how you can implement the tree and how you can add nodes and likewise to the tree, right? So that is what we are going to discuss. So these are the learning outcome. As I tell you always, you can, after the lecture, please visit these and see whether you can do these things. If you can do these things, that means you have followed the lecture well, right? Okay, now into what is classification, right? So here it says classification is a supervised learning approach that I already told you. Classification is a supervised learning approach where, in which the computer learns from the data. Of course, the computer learns from the data in supervised and unsupervised both. Only thing is what the purpose is different. Classification, what you do is this data you give is labeled for one thing, right? And other thing is the purpose in the sense, for example, what you do in the classification is you give the data and ask the machine to predict something. Clustering, it's not something like that. It's going to just identify the patterns, right? So classification is very widely used in practically and research. So it is capable of categorizing unseen example into predefined classes based on set of training example. For example, as I told you, if you can remember in the first lecture, so if you have certain profiles of people who have gone for some credit card offer, when you get a similar profile, you can give it to the machine and ask, like, I have this kind of profile, what will be, whether will he go for the offer or no? And machine will be able to answer that, right? So that is what you mean by this third bullet, right? So application of classification, there are so many. One example is banking loan applicants could be classified as risky or safe. So will he be able to pay the loan or not? That is risky or safe. That you can do by checking with the previous data, not for that particular person, but different people with similar kind of profile, you can check and understand, right? And marketing, whether a customer with a given profile will buy a new computer or not, that could be guessed, right? So similarly, credit card offer, will he go for the offer or not? That can be done. In medicine, the treatment type to be received by a patient could be predicted. So you have these kind of symptoms, what is the best treatment? Is it 1, 2, or 3? That can be predicted, right? So classification, students, when you are actually doing it, you have two steps. One is a learning step, other is classification step. So simply you can call them as training and testing as well. This is training, this is testing and validation, right? So what you do in phase one, which is learning step, is you are going to develop a classification model. So basically you are giving some training data and the machine is learning by self and it's developing a model. And what is this model? Let's assume it's like a set of rules, right? So the looking at the data, it's identifying the patterns, right? What you do in the classification step is, in this step, classification model constructed is used to predict class label for new data. So here you have a training data set. That is training data set. That is you are going to use for developing the model. Then you might have testing data set. Testing data set, right? That is the data which you are going to test the model with, right? Training and testing. Usually what you do is, let's say if you have 10,000 data, normally what you do is you divide this into two parts like training and testing. That is what you normally do, right? Let's say this is 80,000, sorry, 8,000, this is 2,000 or something. So you have 80 to 20 ratio, right? Normally the training data set should be larger, okay? Training data should be larger, testing data should be smaller. So 80-20 is an acceptable ratio between the training and testing sample. Okay, right. So here is an example. You might not understand this very well, but there's another example in this particular lecture slide. You will understand it much better. So here you can see now training set and testing set is there, as I told you, right? So these are students' attributes. You can clearly see this. This is the class, okay? Or you can call it as label. And you can call it in many names. That means if you have these features, answer is no. That's basically the answer, right? So if you have these kind of features, again, answer is no. Likewise, you have a data set. Basically, this is a category, class, or label, right? So you give this data to the machine. So using some learning algorithm, the machine is learning the patterns between this data and it's developing a model. It develops a model. Then it's going to apply this model for test data set. Now look at this. Test data, the label is not there. So what is the machine supposed to do? It is supposed to predict this label. Is that clear to you, students? Is that clear? Is it clear to you what is, do you have a rough idea like what is happening? How you will do it, you will see later. Is it clear? Okay, I hope it's clear. In absence of any remarks, I will assume that it is clear. Right, okay, good, thank you. Right, so here it says, during the learning step, the classification algorithm builds a classifier, or we call it as a model, by analyzing or learning from the training data set. So mainly we are telling that machine is learning from the training data set, right? Training set consists of tuples and their associate labels. In this case, tuple means attributes, right? Now you have seen it in the previous slide. Attributes and the class label or the category. Class label is categorical. You can have labels like safety and risky, or you can say treatment ABC, treatment 1, 2, 3. Likewise, you can take, right? Each tuple is belonging to a predefined class as determined by the class label attribute. So it is having a predefined class, and you can't have, let's say it is yes and no. That is not like that. It is predefined, right? One of these classes it should be. Tuples make up the training sets are randomly drawn from the data set under analysis. Now let's say like I asked you to say in the previous slide, I said like if you can say if you take 10,000 data set, you want to draw 8,000 from that for the training data set. So probably drawing the let's say the first 8,000 might not be a good idea because we don't know how they are ordered, right? So best thing is you draw them randomly, right? You are going to draw random 8,000 values from this 10,000, not in a particular order. Since the class label of each tuple is provided in the learning step is known as supervised learning. So here, remember, I said when you are using a label data set, we call it as supervised learning. Here is the example I told you about, students. This is actually learning step only. Now here is some data. You can see the data, actual data set. This is actually these are actually attributes. This is a label, right? So this is also attribute, but this is not actually useful for our analysis. Depending on the name, you can't predict something. Normally, it is not possible, but depending on attributes such as age and income, you can predict something, right? So suppose you give this data set to the machine. So it says if it is youth and low, it is risky. Likewise, let's say this is the loan decision. This is a loan decision, right? You give it to the model, give it to the classification algorithm. Then it is developing the model. As I told you, let's consider this model as set of rules, right? Now look at the rules it has been generating. If age is equal youth, then the loan decision is risky. Is that correct? So if it is youth, always youth is only in two places, right? Both places it is risky. So looking at this data, now remember machine will develop these rules looking at the data it has only. It can't do anything else. So it sees there are two rows, both are risky. So it will say if the age is youth, then the decision is risky. If income is say high, then the loan decision is safe. So income is high, it is safe. So that's another rule. Likewise, it's generating set of rules. Now the next time you do, students, classification step, we will use the same example. But before that, let's complete the theory. Here it says, during the classification step, test data is used to estimate the accuracy of the classification step, right? So here what you're going to do is, you are testing giving some test data, and you're going to check whether your model is predicting as you want it. That means, is it accurately predicting, right? The accuracy of the classifier on a given data set is the percentage of test tuples that are correctly classified by the classifier. So if the percentage it is correctly classified, that is a percentage for that is accuracy. Okay. The associate class label of each tuple is compared with the classifier's class prediction for that tuple. Now what is this? Let's see what is this, right? If the accuracy is considered acceptable, the classifier could be used for future data tuples. So if the testing is having enough accuracy, you can actually put it into use, right? So let's look at example, same example actually. Now this is your test data. It is now, remember one thing, it is also having the labels, but when you are giving to the model, you don't give that. You only give them the attributes. For the model, you don't give the label, right? You are giving only the attributes. So this model has to predict these values. Now remember, students, at the testing phase, you know the labels, but you don't give it to the model, right? So suppose now for the first row, machine is predicting risky, right? For the second row, machine is also predicting risky. For the third row, machine is predicting safe. Now, what is the accuracy level? What is the accuracy? How many predictions are accurate? This is the actual one, this is the predicted one. But how many are actually correct? How many are correct? I have written them on order, right? I ask you to do it. Assume that this is in order. So how many are correct actually? Correct tuples are 2, right? Isn't it? So first one, if you say this says safe, actual one is safe, but the predicted one is risky. That means out of 3, only 2 are predicted properly. If you take it as a percentage, you can say the accuracy of this model is 67%. Is that clear to all of you? 67 is usually not an accepted model level of accuracy, right? So you might have to improve it by using test data likewise. I hope it's clear to you. Now let's look at the techniques, actual techniques you have. So these are some techniques. You have name-based classifier, support vector machine, k-nearest neighbors, decision trees, random forest, neural network. All these techniques are there, right? So we are actually learning the very simplest technique out of that, which is the decision tree. Why? Because it's easier to teach. But these other techniques like neural network, support vector machine, random forest are very powerful classification techniques. So when you have free time, please go and search about this and see. Get some code sample and run it and see. Because this will help you in your fourth year research also. If you are doing something, anywhere if you are doing machine learning, deep learning kind of research, this kind of knowledge will be useful for you, right? Even if you are doing deep learning, this kind of understanding of machine learning might be helpful for you. So please go through that, right? So now let's see what is a decision tree. Decision tree you have already seen, students. I'm sure you have seen decision trees in first year, second year likewise, especially in software engineering model. Decision tree is a flow chart like structure, right? So what is it having? It's consisting of decision nodes and branches. And you know the tree terminology. So topmost node, what do you call it? You call it as a root node. The lowest level bottom nodes, you call it as leaf node. So this is a tree terminology. I'm sure you have learned this if in a data structures module as well. Root node and leaf node. Have you learned this? Just the terminology. I'm not asking you to do anything else. I'm asking whether you know these terms. You know, right? Right, you know that. Good. So beginning at the root node at the top of the decision tree diagram, attributes are tested as decision nodes, right? So what you have is, now you have nodes. Now we said you have nodes and branches. At the nodes, you test a condition for attribute, right? Each possible outcome at a decision node results in a branch. Each branch then leads to either another decision node or a terminating leaf node. Let's look at an example, right? So for example, here is a decision tree. What you have is at decision nodes, what you have, students? At nodes you have attributes. So how many attributes are there? What are they? Look at this and tell me. What could be this? What are the attributes you might have in this particular data set? You have three, isn't it? Savings is one. Other is? Savings is one. Assets and income. So you have savings, this attribute, right? Asset is another attribute, income is another attribute. What are the class labels? Can you tell me and guess and tell me what are the class labels for this one? Attributes are this. You should have a class. What are the class labels, possible ones, according to this tree? Class label is outcome, right? Outcome is what? What are the possible outcomes for this particular decision tree if you take a look at it? No idea? I'm sure you can get it, right? Very good. Savings is, so what? Basically, whether it is good risk or bad risk. Those are the class label. Good risk or bad risk. How do you know that? Decision is at the end. So here you can see bad risk, good risk. Bad risk, good risk. Here also good risk, right? So now you can see, now each attribute have different values. For example, savings, the possible value are low, medium, high. If it is low, you go in this branch. If it is medium, you go in this branch. If it is savings, you go in this branch, right? Right. So in the next two slides, actually, these are explained. I'm not going to go through all of these because I'm sure you understand. Potential customers are classified as good or bad credit risk. That is a label. Therefore, the target variable is credit risk or the label. Target variable or label is credit risk, right? The predictor variables are savings, assets, income. That means using savings, assets, and income, you are predicting whether it is a bad risk or a good risk, right? Data set is partitioned or split according to the values of the attribute. Those records with low savings are sent via the leftmost branch, and this one in the middle, and this one in the high ones are sent in the rightmost branch. So I'm not going to read this out for you. You can already see this, right? For customers with low savings, next decision node is whether it is having low assets. So if it is low, you check the assets. But if it is high, you are checking something else. If you are medium, you are quite sure it is a good risk, right? So that is how the decision tree is implemented, right? Okay. Now we are going to see how you can construct a decision tree. So before that, students, let's see now you have to do when you have to build a decision tree. First thing is you have to think about how to break your branches, how to test your conditions likewise. Now let's look at how you can do that, right? Splitting depends on the attribute type. Of course, based on the attribute type, you have different ways of splitting. So attributes types are nominal, ordinal, and continuous. So nominal is you have some categorical data. There's no order in the categories, right? Ordinal means it is still categorical data, but it's kind of there's an order. There's a particular order here. Continuous, you know, age, height, likewise, these are continuous, right? Splitting in a tree, you can do multi-way split or two-way. That means you have two branches. This is two-way split. You can have multiple branches also, right? How many branches you can have, right? So let's see how you can example for each of these categories and how you can split them in these two ways, right? For example, nominal. Here is a nominal attribute. What is a nominal attribute? It is car type. Possible value for car type is, there are three. One is family, other is sports, other is luxury. It's given like that, right? So when you are splitting it multi-way, what you can do is you can put, now you have three categories, three possible values. So then you can have three branches. That is if you are using multi-way, right? If you want binary split, of course, you have to group two of these together. Maybe you can put sports and luxury together, or family and luxury together. Or if you want, you can put, what is the other one? You can put family and sports together. Likewise, you can split. When you are putting binary, you have to group them because there are three occurrences. You can't have three branches because that is multi-way. When you want to put it in binary, you have to group them together. I hope it's clear. Right? Okay, let's go on to now this is ordinal. Now when you have small, medium, large student, there's an order. Isn't it? Small, medium, large means there's an order. You can't say small, large, medium. There's an order, right? So if it is multi-way split, of course, you can again put it in different branches like this. Now you have three partition, three possibilities for the attributes. So you can put three branches, right? But if it is binary split, what do you have to do? Binary split, probably the good idea might be which are together to each other, which are nearer to each other, you can group them together. For example, small, medium, large. So small and medium you can group together, or maybe medium and large you can group together, right? So that is the binary split. Okay, this is for ordinal attributes. Let's see the continuous attribute next, right? So if it is continuous, let's say something like salary. So let's say a person's salary in your data set deviates from 8,000 to 200,000. Then what do you do? Multi-way, you can propose some ranges. For example, 10,000 to 25,000, 25,000 to 50, 50 to 80. Likewise, you can propose some ranges and you can have multiple branches. Or you can just have one value, check one value and say, okay, is it greater than this or less than this? Somewhere in the middle. Now here it is taken as 80,000. Somewhere in the middle you take 8,000. You are checking, okay, is it less than that? Is it greater than that? Up to this, is it clear, students? Up to this, is it clear? We have discussed very simple examples. Is it clear to you? Right, good. Let's continue. Good. Thank you. So let's move on into requirements for a decision tree. So what are the requirements when you are developing a decision tree, right? So decision tree algorithm represents supervised learning and as such pre-classified target variables. You need, of course, because it's supervised learning, you need a label data set. That is one thing. The training data set should be rich and varied, providing the algorithm with a healthy cross-section of the types of record for which classification may be needed in the future. Now that is very, very important, students. For example, now let's go for our very initial example. Now here you have youth, middle age and senior, right? Suppose this senior also are not there in the training data set, then can you test something for the seniors in the testing phase? You tested, you will not, right? Isn't it? So that is why, because all the possibilities you have to consider and include in your training data set. So if you are missing some possible values for this, that means that your machine will not learn how to deal with those. So that's why it says it should have a rich and varied, and it will give a cross section of the types and records which might be needed. Right, and the target attributes must be discrete. That means you are not using your class label is discrete. It's not a continuous variable. Okay. So when you are implementing decision tree, students, how you implement the tree? There are so many algorithms. One is Hunt's, CART is there, ID3 is there, CR.5 is there. These are also there. So we are actually looking at CART. And these are algorithms you can use to implement the decision tree, right? So CART of course stands for classification and regression trees, right? So important thing is the decision tree produced by CART is strictly binary. That means what? Every node is having only 2 branches going out of that, containing exactly 2 branches from decision node, right? CART recursively partition the records in the training dataset into subset of record with similar values for the target attribute. Basically, that is what this algorithm is doing. So you take the similar values for the target label, rows with similar value for the label, it's grouping together. And it's partitioning basically, and it's going to look at the rule which can be applied for that. Okay. Right. Now here it says the CART algorithm grows the tree by conducting for each decision node an exhaustive search for all available variables and all possible splitting values, selecting an optimal split according to the following criteria. So what is this? I will explain when you go to the next slide also. So creating a CART model involves selecting input variables and split points on these variables until a suitable tree is constructed. For example, as I told you, so let's say if the salary is varying from 8,000 to 20,000, you have to determine the split point now. Now you want to develop a binary tree. Then what is the value you are going to test here? If it is something like 8,000, it should be 80,000. Less than this or greater than or equal to this. Now this point you have to, this value you have to determine. So how do you determine that? That you have to see, right? So CART model, now you have to select the input variables. What do you mean by select the input variables? Now if you can remember, students, previously there were 3 variables: savings, income and assets, isn't it? So if you are developing a decision tree with this, one thing you might want to know is what is your root node. Now in that example, savings was put as the root node, but you really don't know whether it is the most suitable one. So out of this, which one is going to be your root node? And once you select the node, how are you going to now? Let's say you select savings. Savings have 3 possible values, isn't it? What is that? Low, medium, high. So now you want a CART model. CART is binary. So you have to group them together in some way. That also you have to determine, isn't it? So those decisions you have to take. So how we are going to take that decision, we will see. The selection of which input variable to use and specific split or cut point. Split means in this case, let's say this is the split criteria. Low and medium together, high and high is another. Right? That is a split criteria, right? Variable is savings. Now, did you understand, students? You have to identify which variable to put and how you are going to put the branches, basically. That is what you mean by splitting. Is it clear, students? Is it clear? Right, good. Right, thank you. So in greedy method, now we are using the greedy method in CAST. What do you mean by greedy method is basically you are trying all of these attributes. Is this the suitable? Is this the suitable? Is this the suitable? And if you say, for example, 8,000 to 20,000 you have, 20,000 you have, or 200,000 you have, then there are so many possible split values. So you have to check all these possible values and see what is the best one. That is what you mean by greedy method. Okay. The split with the best cost is selected. So we are considering something called cost here. We are selecting the best. Now, if this one, now you have 3 attributes. So out of this, the one which is given the lowest cost is the one we are going to select. So there are ways to calculate this cost. Let's see using what kind of measures, right? Okay. Now, you can read this slide and see if you understand, see for a moment, go through it and see whether you understand this slide. I have been talking for a long time now, so see whether you can understand this. I will give you a minute. It might not be very clear, but you can go through it. Okay, at least some part of that should be clear to you, right? The splitting criterion tells us which attribute to test at node, a particular node where what is to be tested, and what is the way to separate. Separate in the sense, what is the branch? What are the branches you are going to put? Is it small and medium together or medium large together? Likewise, okay? The splitting criterion also tells us which branches to grow from the node n with respect to the outcome of the chosen test, right? So you are going to test that also, okay? So the splitting criterion is determined so that ideally the resulting partition at each branch are pure as possible, right? So what you mean is, that means, for example, when you have a large data set here, and when you are putting these branches, this is one set of this data goes in this way, another set goes in this way. Discussing was, what do you mean by a pure partition, right? So what do you mean by a pure partition is, I will come to the example once again, show you example. So now think our previous example. So they was having savings, income and assets, isn't it? So what I'm telling you is, for example, now we know the labels also know risky and not risky, right? Risky and not risky. So what happens, student? In our savings have 3 possible values. So let's say you grab hold of, you are getting hold of all the rows with savings is low, and they are going in this branch, and for all of them it is risky. Then we call it as a pure partition because the decision is clear, isn't it? So if the savings is low, it is risky. But it doesn't happen always. Normally, when you say low ones, there might be risky ones and not risky ones also. In that case, it's not very pure. Is that clear, students? Is it clear? Did you get an idea? Is it clear? No response. So I hope it's clear. So if it is unclear also, you have to tell, right? Right, it's clear, right? So if you understand that much, it's good. So we will see it more when we go on to example, but understanding that was also important, right? So now we are going to look at how you are going. Now we said like we have to select the attribute, we have to select the splitting point. How you are going to do that? You do it using an attribute selection measure, right? Which is a heuristic for selecting and splitting criterion that best separates the given data partition D of class label training tuples into individual classes. Right? It's a heuristic. It means a value you can get for selecting the splitting criterion that best separates data into partition. How do you partition this data? This partition and this partition. That is a attribute selection measure is something that can determine. Okay. The attributes that having the best score for the measure is chosen as a splitting attribute. So example, if you have savings, if you have income, if you have assets, if savings is getting the best score, you put it as the starting node. The next one you get as best, you put it as the next node, likewise, right? So there are many measures you can use for this. One is information gain, other is the Gini index. So we are using the Gini index. So let's see how the Gini index is computed using example. Here it says Gini index is used in CART. We are going to learn because of that. Gini index measures the impurity of a data partition or set of training tuples. So that means now we have, what is our example? We have large data set, subset of go into this part, right? If the subset, if all are not in one class, then it is not pure, right? So this is the measurement you can use to find the purity of the partition, right? Can you please write down this equation? You will need this. So this equation is to find out how pure this partition is, right? How pure this partition is. Large set is there, subset you are putting in this branch. That branch, this partition, how pure is, this is how you compute. Let's see an example, right? Don't worry if you don't understand this. So PI is the probability that a tuple in D belongs to class I. So you might have several classes now, let's say ABC. So what is the probability? This tuple is in A. Then other possibilities are also there. What is the tuple? Probability of tuple being in class B. That is what you are basically doing, right? Okay. Now here is another, now this is also Gini index. Now, this is the equation that you can use to find out the quality of split. Please note this one also. Quality of split. Right? This is also Gini index example. When node P is split into K partition, the quality of split is computed as this. This is how we do that. Please write down that also. So number, what is this? These ones also please copy, okay? When you have done, please let me know. Okay, done? Yes. Right, probably done. Huh? Okay, good. Let's look at an example how to do that. Now the first equation is to find out the purity of a partition. So that can be used. Now here is how you can compute it. So for that, basically what you do is for that particular node, now that particular branch, let's say node, no, some subset of the data you are getting here. You are looking at that time, you are computing a matrix, right? Okay, cars, sports and luxury, how many of you are there in A and how many of you are there in B, right? So likewise, it's going to compute. Now here, what is the purity now? What is now sports and luxury partition? There is class 1, there are 3 items belonging. Class 2, there are 2 items belonging. So how do you find the purity of this partition? Is the equation is the first equation. Remember, first equation is what? 1 minus this one. This particular equation. How do you find it? 1 minus. Now there are 5 rows in total in this partition. Out of that 5, 3 is in first class. So 3 divided by 5 square, and this one 2 divided by 5 square. This is what you get. Is that clear, students? How do you do the computation? Is that clear? Is it clear? For the second partition, look at that. That is also having 5 rows in total. So first one is having 1 out of 5. The first is in one class. Other 4 is in another class. So 1 minus 5 square minus 4 divided by 5 square. Is that clear? It's not 1 minus, 1 divided by 5. I said 1 minus, I guess. Is it clear, students? Is it clear? Right. So then, how do you compute the, now we have to now, for the Gini index for the node. Node is car type. Then you have to use the second equation, this one. How do you use it? Gini index for car type. How do you compute? You are going to compute first partition altogether, there are 5 rows. Second partition, there are 5 rows. Total is 10. Right? So first partition, if you take, there is out of this 10, 5 is there. And its Gini index is 0.48. So you multiply. Is it clear? The second partition also, 5 out of 10 is there. That Gini index is 0.32. Is that clear, students? Is it clear? Anything you want to note down, note down. Is that clear to you? Is it clear? Right, good. So you can clear, no? Right, let's, it's clear to you. All right, let's look at an example. Let's look at an example. So these 2 slides I'm going to skip. I will come back because without learning, without getting a brief idea about what we are going to do, you will not understand this too, right? So let's go to the example directly. Now it says, construct a decision tree based on the given data set, right? Split the annual income attribute at 80K. That because now this is a continuous variable. Because of that, there are so many possible split values. So it's asking you to take it as 80K. Why? Because you don't know the split value. You can get it. How you can get it, I will explain when we go to the 2 slides I have skipped. Right? So here's what I'm going to do. I'm going to copy it into my Excel sheet. Right? So I will copy it to my Excel sheet. If you have the slide with you, please do this. Please do it with me. So it will be easier for you. Take it to an Excel sheet and do it. If not, you can look at the slide and do it also. So let me reduce this a little. Okay, right. Now, what you have to do, students, is something like this. So I will shift this down. Now you have to find out, first thing is you have to develop the count matrix. That means now how many attributes are there here? You have 3 attributes. The last one is a class. Now, for each attribute, you are developing a count matrix. How is that? You can say homeowner. Now, what is the class? Class is there as there are 2 classes. One is what? If you look at this, there are 2 classes now. One is yes, other is no. Now, what are the possibilities for homeowner? That is also yes and no, right? Okay, so let's, yeah, I think I did a mistake. Okay, let me fix it. So it should go here. Right, this is class. So I will merge this one So here it is. Now students, how do you fill it? How you fill it is something like this. It's very easy. So what you can say is, okay, now tell me, when homeowner is yes, decision is yes, how many rows you have? Homeowner is yes, decision is also yes, how many rows you have? How many, homeowner is yes, decision is also yes. How many rows you have? How many rows you have? None, zero, right? Okay. Homeowner is yes, decision is no. How many do you have? Homeowner is yes, decision is no. How many you have? You have 3, isn't it? Right. So what you have to do first, students, is compute the metrics like this for all possible all attributes. That means, for example, next one is marital status. Class is still the same. You have here, of course, you have 3 possibilities, that is single, divorced, and married. Right? Married. Right? So what, okay, let's, I will just, here you have 3 classes. The next one is your income. Now the split point is given, what is that? 80K income. So I will put the class as less than 80K or greater than or equal to 80K. Now your first task, I will give this task to you to fill this matrix. Fill this matrix. After that, now you have seen the Gini index equation in the previous one. Do this particular computation. Find the Gini index for the partition and Gini index for the attribute. Right? So can you do that? Can you okay? Fill the matrix first. Okay, I will show you how to fill. Anyway, you have seen the equation. First, fill the. I will give you 5 minutes. First, fill the count matrix. Then, see whether you can compute the Gini index just the same way this has been done. Right? See whether you can. I will give you 10 minutes. See whether you can do it. So that's not hard, is it? So what is the next values for these two? These two, what is the value? Homeowner, no, there are seven. That means this altogether 10 rows. 3 is in this partition, 3 is in yes partition. That means no should have 7, right? So what? How is it divided? Homeowner, no. Class is yes. How many you have? It's 3, right? The other one is 4, right? If this one is 3, other one should be 4. Why? Because it's the way altogether you have 7. Now this one. If it is single you have in 4 places. 2 are yes and 2 are no. That means 2 and 2. Divorce, if you have 1 is yes, there are 2. 1 is yes, other is no. So 1, 1. Married, you have 1, 2, 3, 4. No, there should be 5, isn't it? Yes, there should be 4. 4 is correct. This is no, this is no, this is no, and this is no. That means you have 4 no's and 0 yes. Is that correct, students? Is it correct? Right, good. Thank you. So let's move on to the next one. 8 is less than 80K and greater than 80K. So less than 80K, you have this one. Decision is no. This one, again, decision is no. This one, again, decision is no. That means 0 and 3. Is that correct? Is that correct? 0 and 3? Right. What is the next one? Greater than 80K. Greater than 80K, you have 1, 2, 3, all are no. This one is yes. This one is yes. So basically, I think 3, 4. Is that correct, students? Right, good. Now you have to now now these students, for example, this is a pure partition. What do you mean by a pure partition? I will explain it right here. So if the homeowner is yes, decision is clear, isn't it? Homeowner is yes, decision is clear. It's no, right? That is what where you can see a clear decision is what you mean as a pure partition, right? So we will need that knowledge later. Anyway, so before that, let's continue the compute the Gini index now. Yes, I'm not going to do the whole computation. I will show it to you for the first one. You can continue for the next one, right? So Gini homeowner, not sorry, homeowner. I will just put it as HO is equal yes. That means this particular partition. How do you find out the Gini index? 1 minus 3 divided by 7 in this part. Sorry, that is wrong, right? That's wrong. Sorry. Yes. Yes is not 7. Yes is having 3 to 0 divided by 3. Right? This one. 0 divided by total is 3. Right? And 3 divided by 3 square. This is what? You get 0 if you do it. So Gini homeowner is equal no. Then how do you get 1 minus 3 divided by 7 is your first value, first class. Next one is 4 divided by 7 square. What is the value, students? What is the value? So I will also take my phone and do the computation. That is what? 3 to the power 3 is 9. 9, 16 divided by 49 minus 1. It is, sorry, minus 1. What is the value? You get 6. Is it 56? No. 9 and 16, isn't it? 9 and 16 divided by 9 and 16 is 25. 25 divided by 49 minus 1. It should be 0.489. Ah, yes, yes. I got your point. Anyway, 0.489. Okay, so that is the computation. Is it clear, students? Is it clear to all of you? Is it clear to all of you? Right. So that is for the partition. Now you are going to find the Gini index for the node. That means Gini homeowner or the whole partition. How do you do that? Second equation. So first partition, there are altogether 3 rows. Next one, you have 7 rows. First one, 3 out of 10. Now altogether, there are 10 rows in the data set. Okay. 3 out of 10 should be multiplied by 0. Right? 7 divided by 10 multiplied by 0.489. Is that clear how you get it? So what's the answer? 0.489 into 4, 7 divided by 10. What do you get? You get 0.342. 0.342. Is it clear how the computation is done? Is it clear how the computation is done? Right. Good. Then can you do for the next two and get the value? Can you write the answer for the next two? Same thing. Gini single, Gini divorce, Gini married, and Gini marital status. Likewise, find out the compute the next one also. I will give you, let's say, 3 minutes. See whether you can do it. This is for you to learn. Okay. Is this the answer you get for the marital status? Is this the answer you get for the marital status? Right, good. I'll continue for the next one. This value, of course, is same as this value, right? This is the same 489, so I'm going to take it. Again, this equation is same as this, right? So this will also result to 0.342. Is that clear, students? Is it clear? Right. Right, good. So next now what we do, students, is select the lowest cost. Right? That is what you have to do. Select the lowest cost. Lowest cost in the sense lowest Gini index. So what is the attribute with the lowest Gini index? Lowest Gini index, the attribute with the lowest Gini index is what? It is the marital status. Very good. So marital, then students, what you are going to put as your root node is the marital status in the decision tree. Now that we have done, we have identified the attributes. Now next one is you have to identify the split points. Here, of course, split point is not very clear. So if you had homeowner, it's very clear because homeowner is either yes or no. But unfortunately, our first node, marital status, is having 3 occurrences. So we have to break them into 2 branches because what we are developing is a card tree. Is that clear? Is it clear? So that means, however, you have to bundle these 2 together. Then there's no order also, and see what is the best possible combination. Is that clear? Is it single divorce together and married separately? Is it divorce together and divorce separately and single married together? Likewise, you have to see. Is that clear, students? Right. So the next step is, students, actually, I will not ask you to do that, but keep this in your mind that you have to do it, right? Next step is you have to try out different combinations of 2 for these values of the marital status and compute the Gini index again. For example, divorce separately, single married together. Single separately, married divorce together. Married separately, single divorce together. You are going to compute it again. Right? Then what is the best Gini index you have? For what combination do you have the lowest Gini index? What is the lowest Gini index? For which combination? According to this, what is the lowest Gini index? That shouldn't be difficult. It is what? Yeah, marital status. All of these are marital status. I'm asking combination. Attribute value combination. Which combinations? Now, this is single married, separate. Yeah. Single divorce together. This is the best Gini index, 0.3. Lowest one. Others are greater than that, no? Married, not married, divorced. Single, divorced together, married separately. Is that clear? Is it clear? Married separately, single, divorced together. That is the one which is giving you the lowest Gini index. Is that clear to you? Right. Then that is how you should break your branches. Okay, let's go to the Excel sheets once again. So you have to have married in a, you have to have married in a separate branch. And single and divorce in a separate class. Right. Now let's look at this one and see. Single, divorced and married, right? So if it is married, is the decision clear? Is it a pure partition? Now you can see it from here. Married, is it a pure partition? This partition, is it pure? That means, can you see a clear decision? Yes, you can see, isn't it? If it is married, you had 4 rows, all of them are no. Is it clear? That means if it is married, you don't have to have sub branches further. Your decision is no. Is that clear? Is that clear to all of you? Right? But if you look at this one, single and divorce, there's no clear decision. Some of them are yes, some of these are no. This is yes, this is no. So there's no clear decision. Mean we have to consider and see what is the next attribute you have to put in order to get a decision. Is that clear to you? Is it clear? Right. So here is what you do. So thank you for the feedback. So here's what you do. I'm going to copy this data set. Now, out of this married rows, you don't need, because if it is married, you already know the decision. So I'm going to copy this data set actually, and I'm going to remove the married rows from there because we are not interested with that. We know the decision. If it is married, we know it is no. Right? So let's remove the married rows from here. So how many rows are married rows? This is married row. I'm going to delete this. This is married. That is also I'm going to delete. This is married. That also I'm going to delete. This is married. I'm going to delete that. So altogether I have 7 rows left. 6 rows left. Is it clear, students? Is it clear? Married, there were 1, 2, 3, 4 out of 10. Now it is 6 rows. Okay. Right. Now what you have is, now we have already considered marital status. The marital status we have considered. Now consider the next 2 attributes and compute the count matrix again. We call it as confusion matrix as well. Now compute this matrix again for this particular subset and again for income and find the Gini indices as well. Can you do that? Income less than 80K and greater than or equal to 80K. So that is your branch. So see whether you can fill it with reference to this data set now. This is a subset of that. Fill it. Homeowner yes. Decision is yes. How many you have? Homeowner yes, you have only 1. Decision is, this is 0 and 2, right? Is it correct? Homeowner no, there are 4 rows. Out of that, 1 is yes. Sorry. Homeowner no, there are yes. 3 is yes. Other one is no. Isn't it? Is that correct, students? Now, income less than 80, there is only 1 row. That one is no. This one is 0. Income greater than 80, you have 1, 2, 3, 4, 5. Out of that, 3 yes and 2 no's. Is it correct, students? Is the matrix correct? Is it correct? That shouldn't be that hard. Is it correct? Just the matrix. After that, you can compute the Gini. Okay, is the matrix correct, students? Right, compute the Gini index also. Is this what you got, students? We can check it from the slide as well. Slide is also doing the same thing. Yeah. Is it correct, students? This computation? Computation is correct, right? Right. Now, what is the smallest Gini index now? Smallest Gini index now is what? For which attribute? It is a home mode, isn't it? Home mode is 0.25. Home mode, is it having a PO partition? Home owner, is there a PO partition? Is there a PO partition for homeowner? Homeowner, for any value for homeowner, is there a clear decision? Yes. Or if the homeowner is yes, decision is no, isn't it? Homeowner is yes, decision is no. There's one more thing with yes, right? Right. Then homeowner is yes, decision is no. We are going to put homeowner next. Homeowner is having only one value. So there's no issue in breaking the branch like marital status. Yes and no. Yes is one branch. No is another branch. If it is yes, the decision you already know. It is no. Why? Because here if you go, homeowner is yes, decision is no. Right? But homeowner is no, there's no clear decisions. Three of them says yes, other one says no. Is it clear, students? Is that clear? Up to this, is it clear to you? Right, good. Okay. So now we have only one attribute to consider that you know. Right? So only one attribute, that is we have to consider the income. So anyway, let's do something like this. Now homeowner yes, you already know the decision. What you don't know is when the homeowner is no. So let's collect only the homeowner no rows. So I'm going to remove the homeowner yes rows from here. Okay. Now I have only homeowner no rows, right? Right. Okay. I have this data set now. Is that clear? Up to that point, is it clear? Up to that point, is it clear? Now homeowner yes ones, you know the decision now. So I only do homeowner no rows from this subset, right? Remember, when you are going down the decision tree, you are partitioning, right? From the main set, you took a partition, then that you are going to partition. Likewise, that's how you're going to take. Okay. Now, our income condition is what? Less than 80 and greater than 18. Now tell me, look at this. If you want, you can compute it and see. If you okay, let's compute it. And check whether they are having PO partitions. Now fill this one. I don't want you to compute the Gini index. What is this value for this data set? These two values are what? What is these two values? 0 and 1, correct. Next two values? Next two values? Next row? It is? Three zero, right? Not 20. 30, right? 30. Now, are they PO partitions? Are there PO partitions? Yes, right? So, if you take this partition, less than 80 partition, decision is clear. No, there's nothing with yes. So, if it is greater than 80 also, it's clear. All are yes. This partition is also clear. Also, a PO partition. That means our decision tree can end here when you put these two decisions. What's your decision? Less than 80K, no. Greater than 80K, yes. Right? Let's put income. Income is your next one, in next node. What is that? Less than, no is less than 80K. Right? Less than 80K, no. Less than 80K, no. Right? Greater than or equal to 80K, yes. Now our decision tree has come to end. Is that clear, students? Is it clear, students? So you can look at this and take any decision. So if there's a married person with homeowner, yes, or with a home, decision is no. Sorry, single person with a homeowner, yes, decision is yes. If it is married, decision is no. Likewise, you can construct a decision tree and do the prediction based on this tree. Is that clear to you? It should be pretty clear, right? Right, good. Right. Right, now I skipped 2 slides. I'm going to show that to you. That is, students, now we have considered like how you are going to determine the split point for this ordinal and nominal. You have the idea, right? So if it is a continuous variables, like as I told you, 8,000 to 200,000, there are possible so many split points. Maybe less than 75, greater than 75, less than 100,000, greater than 100,000. So many values are there. Number of possible splitting values are number of distinct values, right? So you have to come with a condition like this, less than something and greater than something, right? So how do you determine which less than which value? Less greater than this value, which value? So that, student, is it's not very easy. So what you can do is you can sort all the values you have. For example, if you have salaries, you can sort the salaries, and you can think about, for example, now we have, let's say, 60,000 to 220,000 salaries, right? So you can put them into ranges. For example, this range is less than, now this is 60 now. 60 is your lowest value. And 220 is your highest value. So let's consider a range. Take a middle value. For example, take something below that, 55. So greater than 55 and lesser than 55. And your 60 and 70 is your next two values mean you can take the mean value, 65. And get, okay, less than or equal to 65 and greater than 65. Again, next value is 75. Again, 70 and 75, you can take the mid value and compute the. Now remember, you are getting the matrix for everything and computing the Gini index also. So once you go on computing for all of these ranges, you will find there's a place where you have the minimum Gini index. That is the splitting point. Is it clear? Is that clear? Is it clear to you? Right, good. So you understood, right? Others, is it clear? You have to consider all possible ranges and find out the Gini index. That is why we call it as it's a greedy method, exhaustive method like this. Because you have to test everything and see where's the splitting point. Is that clear? Right, good. Okay, let's continue the lecture. Actually, lecture again, demo, I'm keeping it to the lab. So now when do you stop splitting a node? So stop expanding a node. So stop expanding a node when all records belong to the same class. For example, here you have seen at the end, all these records are in the same class, right? Then there's nothing further to go on, isn't it? Right? So then there's nothing forward to go. So that's why you put a leaf node. Right? Other thing is, stop expanding a node when all records have similar attributes. Now, students, we have considered only a small data set with 10 rows now. But when you have thousands of data, it is possible that you have several rows with the same attributes. In that case, for all these rows, the decision is same, isn't it? So you stop it now. Is it clear? Is that clear? Right. Okay. Okay. So then, demo again, I'm keeping into the lab. Now, is it clear? So what we have learned, is it clear? Is it clear? Any questions from the lecture? Right. Okay. It's clear to